Okay, we're going to look at an example problem where we start with components and we're going to put those components into vector format. So the problem reads, an object's velocity has a horizontal component, so the velocity horizontal is equal to negative 31 meters per second. And a vertical component, the vertical velocity, equal to 25 meters per second. What is the magnitude and direction of this velocity? So the true velocity, the total velocity, and its direction that that object is moving at. Okay, so these are two components of that velocity. So if we think about what this looks like pictorially, keep in mind that a negative horizontal velocity is going to be pointing to the left. And so there's my 31 meters per second horizontal, and a positive vertical velocity is going to be pointing up. And if I represent that graphically, I'm going to put it at the end, right? And it's really this velocity vector, the resultant, that I'm curious about. Okay? So let's look at what that would look like. All right, well, this is a right triangle. So we know that the magnitude of the velocity is equal to square root of the horizontal component squared plus the vertical component squared. So that's the square root of 31, negative 31 squared, plus 25 squared. And we find that that is equal to 39.8 meters per second. So the magnitude, the strength of that velocity is 39.8 meters per second. Well, what about its direction? We know that using sort of our trigonometry that the angle is equal to the inverse tangent of the vertical component over, sorry, I'm going to say the vertical, not y, because we use v's, over the horizontal component. So if I take the inverse tangent of the vertical, 25, over the horizontal, minus 31, and I plug that into my calculator, okay, I'm going to get the inverse tangent of 25 divided by negative 31. I get a value of negative 38.9 degrees. All right, that's what my calculator tells me. So I have to decide if that's reasonable. Remember, an inverse tangent, a tangent's only going to give you values in the first and fourth quadrant. So this negative is in the fourth quadrant. Is my velocity in the fourth quadrant? Is the direction in the fourth quadrant? If I drew a little quadrant system on this, this is the fourth quadrant. Well, velocity certainly is not in that direction. So this is where we have to be really careful about what our calculator says and what the physics tells us. The calculator is giving us negative 39.8 because the tangent of a vector in this direction at negative 38.9 is exactly the same as the value for that vector. And the calculator can't distinguish what quadrant I'm in. So I have to add 180 degrees. So the real angle that this object is at, its velocity is at, is minus 38.9 plus 180 degrees. And that gives us 141.1 degrees. So, oops, this one. Not that one. So, does that make sense? Well, yeah, because that's in the second quadrant, which is exactly where my vector lies. All right, so keep in mind your calculator sometimes gives you that information that's a little suspicious. You have to look at the physics to decide the proper answer. Good job.